Okay, so now that we've looked at how the Earth's surface has changed from plate tectonics, we're actually going to look at how when we study the rocks that have been moved or changed due to plate tectonics, we're going to figure out what scientists can learn about studying those rocks. So our essential question today is, how does studying rocks help determine events that have happened in Earth's past, happening now, or in the future? So this is essential questions goes with learning target 27. You're going to be able to tell the difference between the three types of rocks and apply the theory of conservation of matter to the rock cycle. Okay, so rock is basically a mixture of minerals. Remember, minerals are compounds or elements. Rock can be a mixture of rock pieces, like broken pieces of rock, which we call sediments. Rock can be also composed of volcanic glass, so pieces of volcano material, and organic matter, which means organic matter is anything that came from once living things. So like our fossils, rocks can contain fossils. There are three major types of rocks: igneous, sedimentary, and metamorphic. Igneous rocks form from the cooling of magma or lava. Oh, I put lava. That's the type of, sorry about that. So an igneous rock is going to form when magma or lava cools. Remember, magma is what's beneath the Earth's surface. Lava is what's on the Earth's surface that comes out from volcanoes. And all rocks will start out originally as igneous rocks. Then rocks can change. They can change either into a sedimentary or metamorphic. A sedimentary rock is when you have layers of broken pieces of rock called sediments. Those broken pieces of rocks formed from weathering. Weathering is the forces that break down the rock, like wind, water, and gravity can break rock into its pieces, the sediments. And erosion moves those sediments. And once it's moved those sediments, then they can be compacted together to make a sedimentary rock. So a sedimentary rock is basically a rock that's made up of pieces of other rocks. And remember, sedimentary rocks are the rocks that can contain fossils. Metamorphic rock is an already existing igneous or sedimentary rock where heat and pressure has been applied. We find metamorphic rocks near plate boundaries, especially near oceanic and continental plate boundaries that are colliding. Because remember, the oceanic plate is dense and heavy, so it will sink below the continental crust. The oceanic crust is made up of rock. When it sinks, those rocks get exposed to a lot of heat and pressure, and that's what creates metamorphic rocks. So that's why we find metamorphic rocks near plate boundaries. So some key words. Igneous rocks come from cooling of magma or lava. Sedimentary rocks form from sediments that have been compacted together through weathering. The sediments were created by weathering and erosion. Okay, metamorphic rocks are already existing rocks where heat and pressure have been applied. Okay, so now let's take a look at the rock cycle. So the rock cycle, if you look at it, let me see if I can get this all in one. Whoops, did not mean to do that. The rock cycle, all rocks start out as igneous rocks. So igneous rocks form when magma cools. Okay, so when igneous rocks form, that's where they come from, magma cooling and hardening. Then an igneous rock can be turned into a metamorphic rock or a sedimentary rock. To get turned into a sedimentary rock, you first have to break that igneous rock down into sediments. You do that by weathering and erosion. If you take an igneous rock and weathering and erosion is applied to it, it creates those sediments, those small pieces of igneous rock. Then you take those sediments and you compact them and cement them together, and that forms our final stage of a sedimentary rock. Now, if we want to take that igneous rock and turn it into a metamorphic rock, we could do that near a plate boundary where heat and pressure is applied, and that will turn it into a metamorphic rock. Okay, so an igneous rock can be turned into a sedimentary rock and a metamorphic rock. An igneous rock can also go back into, get changed back into magma by melting it. So an igneous rock, when it melts, will turn back into magma. Now, and please make sure you're drawing this rock cycle in your notes. Now, if we take a sedimentary rock can get turned into metamorphic rock by the same process the igneous rock can, heat and pressure. A sedimentary rock can get turned back into sediments. You can weather and erode those sedimentary rocks back into sediments. If we want to turn that sedimentary rock back into magma, okay, then we need to melt it. Okay, we need to melt that. And then it will turn back into magma, and then it can turn back into an igneous rock. Now we take a metamorphic rock. We can break that metamorphic rock into pieces by weathering erosion, turn it into sediments, come back those sediments, turn it into a sedimentary rock. We can melt that metamorphic rock, turn it into magma, it'll cool and harden, turn it into an igneous rock. So if you notice, the rock cycle is just showing you how all types of rocks can be turned into other types. Okay, so the last thing that we're going to talk about is the theory of conservation of matter. We've heard this theory a lot this year. Matter cannot be created or destroyed, only changed. So it applies, we talked about how it applies to plate tectonics, how it applies to photosynthesis and cellular respiration. Now we're going to apply it to the rock cycle. So when the rocks get changed, so when igneous rock gets changed by heat and pressure, it turns into a metamorphic rock. It's not destroyed as it gets turned into a metamorphic rock, it's just changed. So whatever you do in the rock cycle, all you're doing is changing. When you melt a rock, you're not destroying that rock, all you're doing is changing the rock from a solid to a liquid, and then it can always turn back into a rock. So that's how the rock cycle supports the theory of conservation of matter. Rocks are not created or destroyed, they're only changed in the rock cycle. Sedimentary rocks can melt and change into magma, but they're not destroyed. Okay, so that concludes our notes talking about how rocks, the different types of rocks, how they support the theory of conservation of matter.